So one of the things we're going to, well, I should say one of the things, what we're going to be doing all this week, test is on Friday of this week, by the way. What we're going to be doing all this week is we're going to be doing application problems of solving rational functions. Okay? So one of the application type problems is something called a work problem. A work problem is a type of problem that involves the rates of several workers and the time it takes to complete a job. For example, the rate at which two painters work and the total time it takes them to paint a house while working together is an example of a work problem. Now, think of it this way, okay? If I paint this room, it's going to take me a certain amount of time to paint a room, right? Let's say it took me 5 hours, okay? Then, let's say Megan decides that she can paint this room too, okay? How long do you think it would take you to paint this room, Megan? 12 hours, okay, right? That's good. I was hoping you didn't say 5, because that's what how long it took me. Okay, all right? So, it takes me 5 hours, it takes her 12 hours, okay? If we team up, okay, how long is it going to take us to paint this room? You have one answer. Without doing the actual problem, how long is it going to take us roughly to paint this room? Takes me 5, takes her 12. 8?
Should be less than 5.
Should be less than 5. Because I can do it by myself in 5 hours, right? So I don't know how long it would take us. We could actually do it. We could figure it out, okay? But it's going to take us less than 5 hours because I can do it myself without her help in 5 hours, okay? So that's the classic trap that you did, okay? You're thinking, well, I just average the two, right? But no, okay? It's not an average, okay? Because why would I ask for Megan's help if it's going to take me longer? You know what I mean? Okay? I want her help. I want it to go shorter. So it's got to be less than 5. Okay? So, Anita and Martin are the assistant managers for the marketing department of the Snarky Larks hockey team. Okay? This hockey season is fast approaching, and the rink board ads need to be mounted to the rink boards before the season begins. Okay? So there's rink boards and all that stuff. Each ad is like a giant vinyl sticker that is stuck to the rink boards along the inside of the hockey rink. It takes a team of 3 people to attach each ad. 2 people to hold the ad while the third person carefully presses it to the rink board, being careful that it does not wrinkle. Up until last year, Anita's team and Martin's team have taken turns doing this job. Anita's team attached the rink boards the first season, Martin's did it for the next, following was Anita, next one was Martin, so on and so forth. They flip-flopped which team had to do it. Okay? So that's the scenario. Okay? Question number 1 says, it takes Anita's team 20 hours to attach all the rink boards, and it takes Martin's team 30 hours to attach all the rink boards. This year, however, their bosses asked them to work together to get the job done faster. Part A. Determine the portion of the rink each team completes in the given number of hours. Okay? So in 1 hour, how much has Anita's team accomplished? 1/20 of the job. In 5 hours, how much has Anita's team accomplished? 1/4, because it's like 5 over 20, which is 1/4. In 10 hours, how much has she accomplished, or her team accomplished? What, Jake? Half, because it's 10 over 20. In X hours, how much has her team accomplished. Say loud. X over 20. Okay. Martin's team. In 1 hour, how much has he gotten done? 1/30. In 5 hours, how much has his team gotten done? 1/6, because it's 5 over 30, right? In 10 hours, how much has his team gotten done? What? A third, because it's 10 over 30. In X hours, how much has his team gotten done? X over 30. Okay. Part B. Consider the amount of the rink that each team can complete in X hours. Write an expression to represent the portion that Anita's team can do in X hours. Well, we said that was X over 20. Correct? Okay. Martin's team, we said, was X over 30. Right? Okay. So, part C. Each team's rate of work is defined as the number of jobs completed per hour. In this case, the rate of work is the number of rinks completed per hour. Okay? So, determine Anita's rate of work. Well, her rate of work is going to be X over 20. Martin's rate of work is going to be X over 30. Okay. Actually, I like their rate of work. I see. I don't like this. Tap the brakes. Let me change that. I'm going to change that. Instead of X there, I'm going to put 1 and 1. Because it's one job in 20 hours, one job in 30 hours. Looking ahead to the table, you'll see why here in a minute. Okay? So, portion of the rink completed. Okay, so she does this. Now, 1 over, oops, she's blue. Not a big fan of this necessarily, this chart. She's 1 over 20. 1 over 30. Okay? So in X hours, then, she's doing, then this is how we got that X over 20. And here how we got that X over 30 portion of the day. Okay? Interesting. Okay? Alright, so now consider the expression from the table that represents the portion of the rink that they can complete when working together. So if they're working together, so if they start, let me go back to the picture of the rink. If Anita starts here and she works that way, and Martin starts in the same spot and he works the other way, the question is, when are they going to get done? You know, they'll probably be somewhere over in here. Okay? So when are they going to be finished? And that's the problem that we're trying to solve. Okay? So question E, okay? Okay, if you want to determine the total time it takes two teams to complete the ring working, what should you spread? Okay, so the expression is you're going to take these rates of work right here, and what are you going to do with these two rates of work? What are you going to do with those two? What are they doing? Megan and I are painting the room together, right? Okay, you're going to do what? You're going to add them together. Yeah. You're going to add those two together because we're working together. Okay? So, write and solve an equation to time. So what are we going to set that equal to? How many jobs do we want to get done? How many rinks do we got to do? One rink, right? So how many jobs do we have to get done? One. Okay? So we're going to set it equal to 1. So let's write it and let's solve it. And let's figure this bad boy out. So x over 20 plus x over 30 is going to equal 1. Okay? And that works if you're in the same units of measure. So let's go back to the room painting. Let's say I could paint this room in 90 minutes. Okay? And Megan can paint this room in 3 hours. Okay? I wouldn't go with x over 90 plus x over 3 because they're different units. I'd either have to make her 3 hours into 180 minutes, or I'd have to make my 90 minutes into 1.5 hours. The units have to be the same in order to do this work kind of a problem. Okay? All right? So, now, from last week, how can we solve this problem? And then what am I going to do with the least common denominator? Multiply it all 3 parts with it. Okay. So what's the smallest number that 20, 30, and 1 go into? 60. Okay. So I'm going to multiply this fraction by 60, this one by 60, and this one by 60. 60 divided by 20 is 60 divided by 20 is 3.
I'm sorry, 3. What is it?
I said 32.
Lots of people said 30. Okay? All right? 60 divided by 30 is? Clearly. 60 times 1 is 60.
It's been a long day. So
It has been. Not even 10 o'clock yet. 3x plus 2x, 5x. Divide both sides by 5, x equals, and what is 12? 12 hours. So it would take both teams 12 hours to complete the task if they are working together. Okay? So if the teams worked together attaching rink boards for 4 hours each day, how many days would it take them to complete the job? Take them what? 3 days. Okay? So, back to room painting. What did I say? I said 5 hours? You said 12? Okay? So if it takes me 5 hours to paint this room and it takes Megan 12 hours to paint this room, set up an equation for me to figure out the total number of time or total amount of time it takes us to paint this room. What's it going to be? What's the equation going to be? X over 5 plus x over 12 equals 1. Okay. Least common denominator is 60 again. 60 divided by 5? 12. 60 divided by 12? So that's 17x equals 60. So x is going to be what? 3.5 is what I'm going to say. Is that what you got? 3.5. 3.53? Huh? So if it takes me 5 hours to paint this room and it takes Megan 12 hours to paint the room together, we can do it in 3.5 hours. Okay? Page 645 now has marine volunteering in the community with Sandra. Okay? Figure that out for me. Go. So, Maureen, it takes 90 minutes to water the garden. When they're working together, it takes them 40 minutes to water the garden. Okay? So we need to figure out how they can do that job together, right? Okay? So, because we know how long it's going to take them, okay, I know that if I go Maureen and, we'll go Maureen and Maroon, okay? So it takes them 40 minutes together, and she works at 90 minutes by herself, right? And then, I don't have an S color, so we'll go blue. Plus 40 minutes working together, and it takes her, we don't know how long it takes, I forget what the other, Maureen and Sandra. Okay, so Maureen, it takes 90. It's going to take Sandra X amount of time to do it, right? And we know that they are getting one job done. Now, mentally, if it takes Maureen 90 minutes to do it by herself, and together they do it in 40 minutes, rough estimate, how long should it take Sandra to do it? Okay. Something more than 40, right?
Yeah.
But less than 90. Okay, so we should be in that 40 to 90 range. Okay, all right. So I would multiply by this factors, or this simplifies to be 4/9 plus 40 over x equals 1, right? So I would multiply every term by 9x. So that gives me 9 divided by 9, leaves me with 4x. X divided by x leaves me with 360. Equals 9x. So 360 here equals 5x. 72. And that is going to be in minutes, correct? Is that in our acceptable range? More than 40, less than 90. Okay? With me? Okay. Checking, nope. Okay, so this week, today, we started 8.1 notes, or 8.4 notes, I should say. Tomorrow we'll do some more of those, a different kind of working type problem, and then we'll give you the homework tomorrow on it. And then on Wednesday, it will be word problems all day long, and we're going to take a formative. Okay. Thursday is review, and then Friday is your Chapter 8 test. Yes, ma'am. Wednesday again? Just Wednesday. All right.